Well, what we're going to run through in our short half hour is the filtered rows percentage method for calculating how you should run a query. We'll spend a couple of minutes on what the optimizer has to decide, and then we'll dive into the filtered rows percentage method itself and how you can use it to tune any query. And at the end, how do you verify the optimizer got it right? Well, that's where you have to validate the execution plan, and we have courses on doing just that. So to begin with, what does the optimizer have to decide to do? The most important decision the optimizer has to make when it looks at a query that's joining loads of tables is which table should it start with, the driving table, because Oracle can join only 2 row sources at once. It has to choose one of them and then go for all the others in sequence. And that choice of driving table is the most important decision it makes, followed by the join order, the order in which it addresses the other tables in the query. And what one could call the silver bullet of SQL tuning is to get the driving table and the join order right. After that, of course, it has to look at the join methods, the access methods, and there are many, many other decisions the optimizer has to make. But the critical one, driving table and join order, and that's what we are going to calculate. Now, as an example, we always do demonstrations. I'm going to work in the SH demonstration schema. In case any of you aren't familiar with it, the SH schema is meant to be a data warehouse simulation. There's one facts table, which is the sales table, and various dimensions. Each sale is at a certain time, each sale is of a certain product, each sale is through a certain channel, and each sale is to a certain customer. And it's a basic star schema with a couple of minor complexities, like the customer's dimension goes out a bit further, but it's a fairly standard simulation of a star schema for a data warehouse. So,
as John mentioned, this schema is available from Oracle. So when you install a database, you get the script to build this set of tables and insert some data. Thanks, John.
Okay. The query I'm going to use for this example is a classic data warehouse query. So look at what I'm doing here. I'm filtering the facts on non-key columns of dimension tables. I'm going to select the sum. I'm going to sum up or project the sum of amount sold. Amount sold is, of course, a table. Amount sold is a column in sales. Describe sales. There it is. That's one of the facts. That's the other fact. And then these are the foreign keys to the dimensions. So I'm going to sum up this fact from sales. Joined to customers, joined to countries, joined to products, joined to times, joined to channels. And there are my join columns to navigate through the dimensions. And then we come to the filters. I'm filtering on the European, where country.region equals Europe. So if we describe countries, it has a region, country region column. And that says whether it's Europe, America, Africa, whatever. So I'm filtering, going back to the previous slide, on a non-key column of this table. And the same with these others. I'm choosing the products, electronics, channels, direct sales, and a couple of times columns as well. So what I'm asking, classic data warehouse stuff, I'm asking what were the value of sales to Europeans of electronics through the direct channel on those dates. You know, this is the sort of thing you would do to work out, is it worth opening your shops on Sundays in summer, that sort of thing. Now this query is quite simple. It's only joining 6 tables. But the same method applies if you're joining 20 tables, you know, a query that's 500 lines long. The same principle for tuning applies. So what we need to do is work out from these 6 tables, which one should we start with, which should we go to next? And for that, we use the filtered rows percentage method. This is the way Oracle's optimizer does it. So in a sense, what we're doing is reverse engineering the optimizer. And that will allow us to tell, did the optimizer actually come up with the correct plan or not? How do we know if it's the correct plan? Unless we can calculate it.
Sorry, John, pardon me. Could you go back to the query for a moment? Students, if you have any questions about this query, anything at all, if you're not familiar with the join mechanisms that John is using in this particular version of SQL, please let us have your questions, because you'll need to fully understand this query in order to fully understand where John is going. Thank you. Sorry, John.
That is important. You have to understand your query before you can even begin to tune it. And as I'm sure some of you will have noticed, I'm using ANSI SQL join syntax here, for instance, which many people still don't use. Now, the filtered rows percentage method. You look at the tables and the filters, the constant filters. So previous slide, there was a constant filter against countries. I only want the countries where, I want the countries by name, where the region is equal to Europe. And there are a few of them. And I'm not interested in the others. So that's a constant filter. It's coming through as a literal in this case. It could equally well be a bind variable, remember. What we have to calculate is how much of the table remains after applying the constant filters. Proportions matter more than absolute values. I'll return to that in a few minutes. Having worked out the proportion remaining in each table, you start with the table that has the smallest percentage left. Not necessarily the table that has the lowest number of rows left, but the lowest percentage or proportion of rows left. If one of your filters were an equality predicate on a unique key, you're going to get one row back, or possibly zero. That would be a good place to start with. But that's an absolute value. The actual proportions are more important, as we'll see. Having done that calculation for all your tables, you put them in order of the filtered rows percentage. And you start with the table where the greatest proportion has been filtered away. Then you move to the next table, then the next table, and the next table. But you have to consider the routes between the tables. And that's why, going back 2 slides, we have this slide up here. You can't join products to countries because there's no route, there's no common column between them. But you could, I suppose, for the Cartesian product. But that's very rarely the best way to do it. So what we are going to do is calculate the percentage to get a join order and then adjust the join order according to the routes.
Query again, John. So question that's come in, let's take a look at the query again, John. The question that's come in is, it seems we're joining sales. Well, let me just give you the question as it's written. How can you join sales directly to countries when customer is joined to countries?
You can't. We have to go through customers to get to countries. That's exactly the point which we'll see shortly. There's no direct route there, but we can join sales to customers and customers to countries, and then we can apply the filter of country region is Europe. And that's what I meant to this bottom bullet point here. You have to consider the routes between the tables.
Thanks, John.
Thank you for pointing this out. Now let's do the arithmetic. You decompose the query into filtering queries. I'll show you what I mean by that. And plug the figures into your spreadsheet. So get Excel out. And here's a spreadsheet I prepared earlier. So in your spreadsheet, list all the tables in the query. And there are 6 of them in this case. In more complex queries, there might be many more. In more complex queries, you might be hitting the same table several times with a different alias. But one way or another, get your tables in there. And for each table, get the total rows. For example, select count star from countries, 23. Okay, mechanical method note. After filtering, well, what does the query say? Previous slide, it says where region equals Europe. So we decompose into that. Where country region equals Europe. And there are 10 of them. 10 countries in Europe, actually, if you want that. And here's the arithmetic. I'm calculating the filtered rows percentage. Just 10 divided by 23 times 100, 43%. So that is telling me that after applying the constant filter, there is 43% of the table remaining. And that's all we do for the other queries, for the other tables in the query. And here are the queries that I prepared earlier. So for all the constant filters, channels. Select count star from channels. Well, apparently there are 5 rows in channels. Oops, channels, 5 rows in
This may
channels.
seem a little tedious, but you will find since you tend to work with a certain number of schemas on a day-to-day basis, after a while you'll know the cardinalities and the percentage off the top of your head. You might be able to rough it out a little bit, but you'll know your data and you'll roughly know what the join order should be, and things will come quicker.
That's the mantra I chant all the time. You must understand your queries. You must understand your data. You must have an idea of what's going to happen with applying filters like this. After applying the filter, there's only one channel called direct sales. For times, there are 1826 rows in times. And after applying the filter, Sundays in August, there are 22 rows remaining. I think I skipped over, products. Yes, there are 72 rows in products. And after applying the filter, prod category electronics, there are 13, sorry, got that wrong. There are 72 rows in products. After applying the filter, there are 13 rows left. And we've got 2 tables remaining, customers and sales, because in the query, there are no constant filters against customers or sales. So the best I can do for those is put in the absolute values, but I can't do any arithmetic beyond that. And it turns out there are 55,500 customers, and there are 918843 sales. But I can't do the arithmetic on those. There are no filters. So that's calculated the filtered rows percentage for each of the tables in the query. What do we do next? Well, we've got the calculation done. You start with the table that has the smallest percentage left. Let me try to explain why you do that. You might think, well, there's only one row left from channels, so surely I could start with channels. I've only got one row. Why would you deal with more rows than you have to? Start with the table where there's only one row. But the problem is that is 20% of the table. So in principle, assuming an even distribution of data, your one row from channels would still leave you with about 180,000 rows from sales. You're going to get 20% of channels will leave you with 20% of sales, assuming even distribution. Well, 180,000 rows, that's a lot to deal with next. Whereas if you look at the times table, after applying the filter of Sundays in August, there are 22 rows left. Well, 22 rows is a lot more than one row, but it's only 1% of the table. So if we start with times and go to sales, we're down to probably only about 1,000 rows of sales that will match. And that's the critical point. It's the proportion that matters, not the absolute value. So you follow the FRP order as far as possible. Like this. I've got my filter and queries, put the figures into the spreadsheet, the FRP order. Well, ideally, I would go from times to products. No, it would be times to products to channels to countries. 1.2 to 18 to 20 to 43. But you can't do that. You can't go from times to products because, going back to the diagram, from times, you can't go to products unless you go across sales. And that's where you modify the join order, the ideal join order, according to the routes between the tables. And what we end up with then is times as our driving table. Then we have to go to sales. We've got no choice about that. After that, we can go to products. Then we can go to channels. Ideally, we would then go to countries, but we can't because of the routes between the tables. We have to go through customers, and then we can go to countries. So that is our optimal join order, bearing in mind the routes between the tables. Times to sales, to products, to channels, to customers, to countries.
John, question had come in, but what about customers that are in Europe? Are we gaining anything by filtering channels down and limiting only customers that are in Europe?
We're applying the channels filter before we apply the countries filter, because the channels will throw away 80% of our facts, whereas the countries will throw away only 57% of the facts. So we can throw away a greater proportion if we apply the channels filter before the countries filter. Did I get that question correct?
I believe so. Thank you.
So having calculated what the join order should be, what do you do next? Well, then we have to go to reading execution plans. Now, what's Oracle going to do to run this statement? Well, there are several ways of doing this. What I shall do is set auto trace on. I'll just use the auto trace facility, and I shall run that query. Oops. Apologies. I can't copy that, can I? Just a second. Right, so we'll run the query. So, and see what Oracle actually did. Just stretch that out. And we'll run it again. So, my query was the query that joined all those tables. Get the query up here. There we go. So what did Oracle do? Well, it ran the query, and apparently the answer is 20,388. Fine. And then we see the plan that it came up with. It's reasonably straightforward, but what we now have to do is see, did Oracle follow the join order we wanted? Well, we have many courses on reading execution plans, and we don't have time now to run through all of that. But what we are doing is we're bringing countries into memory, applying a filter, which is Europe. But that isn't the driving table. We're parking it in memory because we're going to join that to the results of this join. And this join is the result of another join, which is channels being joined to some fancy work on products. That's just an optimization using an index join to avoid hitting a table, which are joining to another join. And only when we get down here do we actually see the join order beginning. We are starting with a full scan of times, applying the filter, August on Sunday, Sundays in August, and that we are joining to sales via a bitmap index. Everything else is just joining tables to other joins. It's only when we get down to here that we are finally joining two tables. And this tells us that our driving table is times. And Oracle expects to get 22 rows, which is not bad. We did the arithmetic, 23 for the full scan. Applying a filter, it's not quite right there. Times 22. Yeah, 22. Sorry, it's estimate is bang on. It's expecting that after applying the filter, and it's correct. And that is joining to sales via bitmap index. The result of that join is being joined to, via a hash join, it's being joined to products. So our driving table is times, which are joined to sales, and then we're going to products. The result of that, having joined to products, we're joining with a hash join to channels in that direction, to channels, which was 20%. That we then go via customers to countries. So the join order Oracle chose was indeed, let's just check as it was as we got here. It started with times, then joined to sales, then we went to products, then we went to channels, then we went via customers to countries, leaving countries to the very end. So Oracle did indeed choose the join order that we had calculated. And this is a basic method for tuning that you can apply to any query. You calculate the join order, then you analyze the execution plan and see, did Oracle get it right? And if Oracle didn't, you've probably found out why the query is running badly. And then, of course, you have to move on to tuning it so that the optimizer will get it right. Dave.
Great. Thanks so much, John. Okay, so there's a question, and then I have some points I'd like to make. First of all, what about a subquery, John, for like sales where XYZ is true and customers are in Europe?
A subquery like that, Oracle will attempt to merge it into the calling query. And if the subquery can be merged, then this same method will apply. If the subquery has something horrible in it, like say a set operator or an order by or something, then it can't be merged. And that's one of the more sophisticated issues with calculating the join order. If it's a subquery that can't be merged, Oracle has to stop what it's doing, generate that result set to completion, and then that can then be plugged into the join order later. But subqueries that can't be merged, definitely a problem, which can be addressed through various ways.
Great. Right, so if it's merging, then it's converting it to a join, essentially. It's undoing what you wrote and converts it to a join, which is
correct. That's a better way of putting it.
You want that to happen. If it can't merge it, because there are some things that you can do in that subquery that are sort of bad, red flags, and it can't merge it, then it has to materialize that subquery. And that's sort of a red flag. It could be a bad path, and you would need to do some testing there. Likely that's going to run slower than if it had to, convert it to a join. So
correct. Red flag is a very good term. It's something that's not necessarily good, not necessarily bad, but it's a big warning that you need to check out if that really is the best way to do it.
Indeed. Okay, so in the chat, you may have noticed I just put a free tutorial on how to read an execution plan. This is a really 5-star tutorial. It's only about 15 minutes. It's a video out on YouTube, and it's done by John, and it's got tens of thousands of views. I think it's coming up to close to 100,000. Now, if you want more than that free tutorial, then there is a class, 2 classes you might be interested in. First of all, there's a half-day class called Execution Plan Essentials. And here's the link to that class. That's a half a day. And that's, if you're new at this, that's a good place to start. Okay. The full 3-day class done in actually half-day sessions for SQL tuning. This is the full SQL tuning class. Send this over to you. Okay. So you've got some links there to where to go for more information. Some of it's free, and there are 2 classes that require that you register with money. The free tutorials, I sent you to one of them, how to read an execution plan. There are a couple of hundred tutorials on our website. So, you may indeed find a lot, and quite a few are related to tuning. Like you'll see one out there, common coding problems, SQL tuning and how to fix it. Okay. Okay. So John, could you go back to your demonstration? A couple of final questions are in the queue. There's an asterisk in front of the number. I think he's speaking on the left side there. Yeah, thank you. What is that?
Whenever you see an asterisk on the left of an operation, it means you need to look lower down. It means there's a predicate being applied. A predicate. Remember, a predicate could be a join condition or it could be a filter condition. But wherever you see an operation with an asterisk, go down there, there's a predicate. For example, operation 14, full scanner times. Asterisk, go down here and see what's happening with that full scan. Operation 14, it's a filter. It's a filter predicate. So that's what that means. Never forget, by the way, that when you look at this column here for the rows, this says absolutely nothing about how big the table is. We have no idea from this execution plan whether the times table contains 50 rows or 50 million rows. All we know is that after applying that filter, Oracle expects there to be only 22 rows left. So that's just an indication there is a predicate on that operation.
Bear with me, John. Yeah, here's a great question, John. What happens if the distribution of values in sales is skewed instead of uniform?
Then we are relying on the histograms and quite possibly dynamic sampling as well. And I gave you my simple example earlier. There's only one row in channels, but that could represent or would represent on average 20% of the sales rows. Well, there are skews on these tables. There are most definitely skews on these tables. And that will throw out this arithmetic. That will throw it out. However, again, it's a matter of understanding your data. You will get a feeling for, or you should have a feeling for the data in your databases about the data distributions. The skew on join conditions is where Oracle's default statistics are often inadequate. And that's where you may have to build up extensions. In the last resort, you may even have to use hints, or my own favorites, use dynamic sampling, or possibly SQL directives. But certainly a skew in the data will distort this. And you're relying on your own knowledge, and possibly Oracle will be relying on non-default additional statistics to take account of that.
There's another great question in here. Oh, geez, I just deleted my answer. Or did I? Wait. No, okay, so do we need to go through the exercise that John did? No, we're hoping that the optimizer, the cost-based optimizer in Oracle, figures out the optimal, the best join order. But if the query is underperforming, then we have to do a tuning exercise. And often we find that the join order is correct. That's the silver bullet. And if the join order is incorrect, you need to find out why that is. Are the statistics wrong, for example? Does Oracle think there's 2 rows in the table when there are really 2 million rows in the table? You'll find things are wrong by going through the exercise that John showed us here today. So no, we want it to We want the CBO to do it for us. I'm going to alter the text on this question just a little bit. John, does ANSI join notation or Oracle old style joins matter with respect to performance?
It doesn't matter with respect to performance one iota. There are very, very few cases where ANSI joins still don't work. I think I came across a problem the other day with materialize view rewrites where ANSI joins didn't perform too well. But so I know of only 2 cases where ANSI join may not function. And my own preference is always to use ANSI join because I find it far easier to read and much less prone to error. But in performance terms, there should be no difference.
If you liked this video, please like it and subscribe to our channel.